everybody, I wanted to spend a little bit of time explaining this lab. This is a exciting lab to write up and interpret, and I'm pretty excited about explaining it to you. So this is the first lab where there's not any sort of lecture about processes in the lab. This one is just has the video explanation right here. And if you want to see the lab, you can go to Professor Sherlock's website. It's in the supplement, also in Blackboard, and it's also it's also copied below here. I have taken the directions at least and put them down here so that you know exactly what's going on. The purpose of this lab would be to make 1,4-dibutyl 2,5-dimethoxybenzene using a Friedel cross reaction. Okay, and so in class, in lecture, you're probably learning about Friedel cross reactions and how they work and all that stuff. And so this is kind of an interesting reaction. And so below are the directions on how to do it. But you want to make sure that not only do you see how to do it, but you also want to get some other information. So before you get started answering the questions, just fill out this data table here. It has the molar mass, melting point, boiling point. You're probably going to need that information to do this, or at least the next couple of questions. And then using that table, just like in the previous lab, you're going to want to calculate how much of each reactant you're going to need in order to make 10 grams of product. Now, I do say that you're going to have to look up the balanced chemical equation because it's not necessarily that everything is in a 1-to-1 to 1-to-1 to 1 to 1 to 1 to 1 ratio. That may throw you off a little bit. And notice also I asked for each reactant. So you want the T-butanol and the 1,4-dimethoxybenzene. Okay, so you'll have two numbers there as your answer. Okay, now the next question is more of a theory question, but I think it's important in understanding how the lab actually works, and that's to propose a mechanism for the Friedel-Crafts alkylation based on the conditions in this lab. A normal Friedel-Crafts alkylation will use a metal chloride and an alkyl chloride in order to do the reaction. In this case, we're using an alcohol and sulfuric acid. So it modifies the mechanism a little bit, but you can definitely do it. I give you a couple of resources. There's a written book and a video on Friedel-Crafts alkylation to get a sense of how it works. Plus you have your general chem notes, plus you have Professor Sherlock, and you have me to ask questions of. So see if you can write a mechanism here, okay? And then at the very end, you're going to recrystallize the compound, and I want to know, why are you going to use recrystallization to purify the compound? So that's a quick answer right there. Okay, so now this is where the fun begins, because this is the first lab that you're going to have NMR to determine structures of the compound. So I give you melting point ranges here, okay, and I give you the yield and the appearance, and I give you a GC. Okay, so here's the GC. What you want to do is you want to interpret the GC. In this case, we are going to assume that this is the product. This is the thing that you desire to make. We don't know what the structure of that product is yet. We just know that that is your main product. That is the thing that is right here. Okay, and what we want you to answer is, what is this little peak? What is this little peak right here? This little itty-bitty peak that comes out at a very, very short retention time. I will tell you that it's not air, but it is a part of the reaction mixture somewhere. Okay, and there's really only one answer that makes sense for this. Okay, so so go ahead and then you want to explain why. Support your answer with evidence. Okay, and then IR interpretation. You guys have been doing IR interpretation for a long time. So again, in order to do this IR interpretation, you may want to draw on here, make annotations. You may want to point at what peaks are what, and then go from there. And then the first proton NMR. This is proton NMR. This is great. And I enjoy NMR a ton. Okay, so with proton NMR, you have chemical shifts and you have coupling constants. In this case, there's not really much coupling. Everything's a singlet. And you have integrations. But here's the data. And I only include, most NMRs wouldn't give you data like this. I gave you the data because it's hard to see. It's a little blurry. So I wanted you to make sure that you have all the data. So what you're going to do is you're going to interpret this NMR, and you're going to see if the information in this NMR is consistent with the structure of the thing that you wanted to make. And so you may want to assign peaks. You may want to explain why everything is a singlet. You may want to explain why there's only 3 protons. You're going to do a complete interpretation of this NMR, and when you do, you just want to make sure that it either supports or doesn't support that you made the product that you made, okay, or that you made the the diterbutyl 2,5-dimethoxybenzene, okay. And then the other type of NMR is proton NMR, and this one, again, you have peaks, and I have a list of the peaks. Again, normal NMR, you wouldn't have you wouldn't normally have the peak table, but I give it to you because, again, it's hard to see the numbers up here and any sort of integration. So, again, you want to see if this NMR is consistent with this structure, okay? Is there a reason why this is 3 and this is 1 and this is 1 in terms of integration? All that is there. And again, you may want to make annotations, and you may want to then explain in here below. So then finally, and this is, again, I think this is the most important skill that we're getting out of lab, whether you're doing it live or whether you're doing it electronically. I think one of the most important things that we want you to be able to do is to write science. Okay, so write scientifically. So in the space below, you've taken all the data, all the information that you have, and you've gathered some results, you've interpreted those results, but now you want to come up with a reasonable conclusion. So you want to write a well-written, detailed conclusion saying whether you made this compound, the 1,4-diterbutyl 2,5-dimethoxybenzene, and whether you made it pure, okay? And you're going to use all the information above to support that. Now, while you don't have to go into complete interpretation of NMR, saying that the NMR supports or doesn't support your conclusion is important, and then explain and give like 1 or 2 points as to why. Again, you don't have to go into the complete description, but adding points from your the most relevant points from your interpretation of NMR and IR is important in your conclusion. Okay, and also, please don't include just a summary of what you did. Okay, that's not what a conclusion is. A conclusion is a supporting paragraph or several paragraphs that support whether you made the pure product or not. Okay, it's not just we did this product and we do it and then we go from there. Okay, it's not just a summary of what you already did. Okay, you want to synthesize all the information in the previous results in the IR, the melting point data, all of that stuff, and then you can synthesize it into one well-written conclusion. And that's really the kind of the goal of writing science. Okay, so I'll stop blabbling on about the conclusion here. If you have any questions, feel free to reach out and ask them. And have a great day, everybody.